Hi guys, this is Xiao. Today I'm gonna introduce my fourth project, which is also like for the extra credit. So this project, as we know, is for graph generation. I implement the graph generator in Python. So I put it. I mean, where I put it is not important, but I just want to show you. So here, we have a map folder here. So I put all this Python script inside map folder. So here's the same folder. That's the script I created here. So I introduce the like what I used to do. Like I introduce the code first, then show you the demo. So to generate a map, like here's the map I generated. So I look at the file first. This XML structure. So to generate this kind of structure, like we had to have the maps and also different entities. So then I create different entity first. I create a base class entity, different entity like player, gold mine, piston, map, and all the entities have the function called like to XML. We will use it later to generate the graph. So then for the helper function, I create a some class like location, which means a point in the graph, and based on location, I also create a square. So now a point, it means like just one brick, like square means like a square area. I will use this later. So that for the both square and location, we have like method, to calculate the distance. Also for the location, we can have the method to calculate the path. That helps me, build a randomly generated graph. So now we finally goes to the like graph generator. So the game state. We'll look at to XML function first. So basically for like this one, so you generate like different values in the class, and for this class, finally you wanted to generate an XML file. Basically, you just for each of the entities, you just call to XML function and add to the XML document tree and do the output. So that's how we generate it, and then finally goes to the main logic how I generate the graph. So there are a bunch of like I designed it basically for a pipeline logic. So it's kind of like uh, pipeline design. There's a helper function factory. So you have different helper function like place player, place cross point, place a draw point, a flatland, different pipeline. So finally, you want to generate graph, you should initialize. For example, I initialize a map with width of 1640, and I play the players first. So you have different players, and you play cross point. So which means like you're based on the player's cross point to like draw different road to each other. Here I use cross algorithm, so like make it or the land not too bored, and then I add flat land based on the player. I expand the land, expand the road from node to node, so make it not too narrow. Otherwise, like the player may stuck in a row. And then I build a tree. Also, in the end, I distribute resource to make the game fair. So I distribute resource basically just balance the tree in like the resource region. So like uh, I use iridiums like from one to another and calculate the resource in the iridiums for each player and finally balance it to make sure like in the iridiums like each player has the same amount of tree. So basically that's the logic. now now I'm gonna show you one of the graph I generate. Okay, so that's one graph I just generated. Um, yeah, so basically you can see, we have water, we have land, we have tree, and we have different role from one player to another, right? Okay, so that's one graph, and I can generate another one now. Let's see how it works. Okay, then now that's another graph. You see, like different style. Try again. Because we use random search, so sometimes the search may stuck in the like local optimum and cannot find a global solution. So I may need to run it multiple times. Here, from one to another. So that's the enemy, and it's all player. And I showed the last time. You see, that's how diagram get generated for the whole graph. So that's it. Thank you.